Hi all, hi everyone. Hope you've all been keeping well. Today is Tuesday, the 20th of February, 2024. Reporting from Auckland as usual. I know I haven't had anything for I think more than 2 weeks now. Spent about more than a week down south visiting one of my basically my best mate from school. Probably one of the best things that has ever happened to me. So visiting him, and we did a lot of cool stuff together. Went on a lot of walks and everything. So yeah, it was good. So I had a bit of time off, but no, here I am. So yeah, this is certainly a very interesting talk video on time travel, whether or not it is possible. Probably at one point was quite a cliche topic, but I think it's sort of a topic that also has not been touched on or discussed in quite a while, probably a good 10, 15 years, maybe more than that. I can certainly relate to time travel. I haven't done it. I wish I could, but yeah, no, growing up watching, the Back to the Future films, the Back to the Future trilogy. Oh, they're my absolute favorite. I've collect Back to the Future memorabilia, how many times I've seen the movies, still love them. In fact, Back to the Future 2, which came out in 1989, has been my favorite movie, pretty much my favorite movie since I was 9 back in 1994 when I first saw it. And still believe it or not, still my favorite movie today. It really is still my favorite movie today. I've got some other movies that I love, but that is still my absolute favorite, even to this day. So whether or not time travel is possible, actually, in theory, in physics theory, or if you like, quantum physics, which is basically the study of time travel, it is entirely possible. And not only that, it has in fact been done, by astronauts in space and all that. I remember watching a documentary about one astronaut who has actually basically time traveled as he has been propelled fractions of a second into the future just through his traveling in space, according to the laws of physics. Basically, the faster you go, the less weight you have. I think it's the less weight you have, not really mass, because mass is a measure of your matter, how much matter, and your mass never changes. You always have, the same matter or the amount of matter or the amount of atoms in you. But your weight, of course, can change, and of course, it changes depending on what planetary body you're on. As you know, you'll be lighter if you're on the planet Mars because it has less gravity, one third the gravity of Earth. You'll be even lighter if you're on the Moon. It has one sixth of the gravity as Earth, and therefore you'll be able to jump, well, theoretically, six times higher than you can on Earth. So that's just certainly something to think about. Um, so your mass never changes, your weight does. So basically, they say as you gain speed or the faster you go, the less weight you have. And what's also interesting is that the faster you go, the slower time goes for you, and the faster it goes for everyone else. And I remember watching a documentary on that. So, say if you were traveling very fast, close to the speed of light, they reckon physicists really think that if you travel close to the speed of light, you can essentially travel into the future because what could have only been, say, 1 hour for you could have been years and years and years for everyone else. So you would essentially travel into the future over the course of 1 hour. You would arrive years and years later for everyone else. And it's interesting. Physicists believe, is you imagine like a cylinder, a vertical cylinder, and with a with a photon, like a light particle bouncing up and down. And say as it bounces up and down, though that's how it measures seconds for you. But as you travel faster and faster, picture that vertical cylinder. The photon just can't go vertically up and down. As the cylinder moves, the photon has to go diagonally up and down. And the faster you go, the more diagonally it has to go up and down. So what happens is that time for you essentially goes slower and goes faster for everyone else. So if you travel towards the speed of light, you can basically travel into the future because what could only be, like I said, 1 hour for you could have been years, decades, maybe even a century for everyone else. So it's quite interesting. They also believe that time doesn't flow at exactly the same pace everywhere in the universe. They believe time flows at different rates at different places in the universe. It can also be affected by gravity. So, on a planet with much more gravity, time could actually flow faster than it does for, say, on a planet with less gravity or elsewhere in the universe. And you might remember that's sort of what happened on that movie Interstellar, starring Matthew McConaughey. I think 2009 or around there it came out. And when they went to that other planet, which was basically a water world, covered by water, and unfortunately they were in the wrong, if you like, time in the wrong place, and that tsunami came towards them. But remember, they said in the movie that an hour there is 7 years back on Earth, so they really have to rush in what they're doing. And unfortunately, it was even worse than that. I think they were there for about half an hour, not about that, and then they came back to their spaceship, and apparently 23 years had passed for their fellow crew on the spaceship. What had been only, say, half an hour or about that for them was 23 years for the fellow crew back on the spaceship. And you might remember in that movie, when he comes back to Earth, certainly a lot of time has passed. Even though not much has passed for him personally. So yeah, so they believe that time flows at different rates at different places in the universe, even on different planets. It's affected by gravity. The heavier the gravity, usually the faster time can go. It's also sort of like what Einstein has said, that he talked about space time. That space time is interwoven, and therefore, if you affect space, you can essentially affect time as well. And I think that's how the gravity works. The stronger the gravity, I think the faster time goes. And usually, in general, they used to think that there were four dimensions, if you like, vertical and then horizontal, and then, of course, the other one, which is, if you like, depth, making it 3D rather than just 2D. Oops, that's my stupid phone going. Going to turn that damn thing off. So they talked about three dimensions, and the fourth one being of time. Time for that object, that three-dimensional object, to move through us in space. So they used to talk about four dimensions, and geez, they used to talk about four dimensions. Vertical, horizontal, and depth, three dimensions, and then a fourth one of time for the object to move through a certain space. And I think Einstein came up with his theory of actually 11 dimensions, 10 physical dimensions, and then one of time. But like I said, they also believe that space and time are interwoven. I remember one thing that really fascinated me was they believe that, yeah, as you travel faster and faster, like we discussed before with the vertical cylinder and the photon, they believe that you will travel basically into the future as time goes slower for you. Remember that photon having to move basically diagonally to go up and down to measure seconds for you. Therefore, it takes longer for you. So time goes slower for you, but faster, or at the same rate for everyone else. They believe that if you travel towards the speed of light, you will travel into the future like that. But what physicists say is that time is a vector, meaning that it's measured in both its amount and direction. A scalar is just an amount. Basically, it's just positive, like, if you like, someone's height. You can't be of a negative height, pretty much. You're just of a height. But time is a vector. It measures amount and direction. So, meaning that it can go backwards, it can go in both directions, not just amount as in, say, 10 years in the future, or 20 years in the future. Stupid phone. I've really got to chuck that thing out. It really is like Adam Sandler's remote, isn't it? So, what some physicists believe, and of course there's a lot in theory, a lot because a lot hasn't been tested. What some physicists believe is that if you travel faster than the speed of light, if you were able to, I think they talked about some particles that can do it called neutrinos. But the speed of light is basically known as the cosmic speed limit, pretty much the fastest you can go according to the laws of physics, or perhaps the laws of physics as we know them, right? But if some physicists believe that if you travel faster than the speed of light, you will actually arrive before you left. In other words, you'd go back in time. So potentially you could actually travel in the past by going faster than the speed of light. So it really makes you think. And then, of course, there are what physicists call time paradoxes. We really don't know what happens unless we, I guess, we have a time machine and we test it. I probably wouldn't recommend that. It probably sounds like something very dangerous. Think of the movie Project Almanac, when they go back in time and they change things and then that person just disappears, from existence. Or even again, the Back to the Future movies, like Back to the Future 2 or Back to the Future 1, where things were, all the Back to the Future movies, when they went into the past and things were altered and it then changed the present. It worked out pretty well for them in the movies, but it might not work out so well for us in real life. And they talk about, for example, the grandfather paradox, and this is exactly what this is something you can apply to Back to the Future 1. You might remember Marty McFly, the star of the movie, accidentally gets transported 30 years into the past from his present time, which is 1985 in the movie, 30 years in the past to 1955. He interferes with his parents' first meeting, so they don't meet, they don't fall in love, they don't get married, they don't have kids, and he's obviously one of their kids, so his own existence, is in jeopardy. But the paradox there is that even if you did that, say you went back in time and you interfered with your parents' first meeting, so they didn't meet and they never fell in love and got married and had you could essentially, you would think, erase your own existence. But if you erase your own existence, how do you go back in the first place to change the past like you did? And that's what they call the paradox, or it's specifically called the grandfather paradox. And again, we might never know unless we really test it, or perhaps if we do more work on these theories of quantum physics, these theories of time. Some physicists have actually speculated that we live in a world, or I guess a universe, or really a multiverse. Multiverse consists of several different universes. That's a multiverse, several different universes. So physicists believe that you have parallel universes. Imagine them as time travels. Imagine them as timelines. Sorry, and again, this sort of goes to Back to the Future 2, when Dark presents on the chalkboard. So I don't know why it's suddenly gone dark. When Dark presents on the chalkboard the different timelines. Basically, if you go back in time, say from today, 20th February 2024, just say to somewhere in the past, pick a date. 31st December 1999. I remember. It was a Friday. Say you went back. There's the existing timeline when you never went back to do anything on that day. But then if you go back from here, you go to a new timeline where you have gone back, and when you do something in that day, on that day. So when you go back to the future or back to the past, it's different. So some quantum physicists believe that maybe that could be the case, different timelines, and you basically travel from one to the other as you change the past or possibly even the future. And some physicists, even like Stephen Hawking himself, has said that wormholes, basically black holes. If you get sucked into a black hole, many different scientists and physicists have speculated what happens if you do get sucked in a black hole, and assuming you actually survive it, what happens. And I think it was Stephen Hawking in the mid 90s who talked about, if you did get sucked into a black hole, basically it's a wormhole, and it bridges one parallel universe to another. And he speculated that if you did get sucked into a black hole through that wormhole, and if you survived it, you would arrive at a different place in the current universe, or you might arrive at a different universe altogether, or perhaps at a different time in the universe. It's certainly very interesting. Well, that's basically what I know about it. So it looks like time travel certainly could be possible. Well, it's been done, even on a very small scale, by astronauts who have been, propelled fractions of a second into the future. So I guess time travel is possible. Certainly a lot is possible according to theory, but I guess we've still got a bit of work to do, and I guess we'll never really know for sure until we actually tested it. But I'm not sure if I would advise against that, even if we did invent a time machine, or if we could. But hey, it's certainly something to make you think, certainly something to discuss, and I think that's a good place to leave it for now. Thank you.